Good afternoon again. My name is Elvina and I will be your moderator today. Welcome to our Dynamic Talks by Grid Dynamics. This edition is in our now office in Moldova, but also we're streaming online worldwide. And we can start with some introduction about our company. But firstly, I need to mention that today we'll have a talk about Composable Commerce, but I will introduce our speakers a little bit later. So now, who we are? We are a Grid Dynamics company. The guys who are in the office can check our office. It is really nice in our inches now. And who are online, also you can check some photos in our social media. Grid Dynamics is a leading provider of technology, consulting, engineering, and data science services for Fortune 5 corporations from financial, technological, and retail sectors. It has been operating since 2006. Is headquartered in California and has development centers in the United States, Eastern and Central Europe. As of today, Grid Dynamics brings together more than 4,000 engineers in 13 countries. Grid Dynamics is a NASDAQ-listed public technology company, and with core expertise in big data, data science, machine learning, AI, scalable omnichannel services, DevOps, and cloud enablement. You will hear about it also today. And on this slide, you can also find some of our clients. Also, we have some job openings, and if you are interested, you can scan this QR code and check them. If you are offline, you can also speak with our recruitment team and check the job openings with them. So thank you, and I think that we can start with our speech about composable commerce approaching the puzzle. And the first speaker will be Octavian Mitu, our senior BE engineer. So welcome, please, our office, you can start.
So let me present the speakers. Hi, everyone, first of all. Myself, as Elvina mentioned, I'm Octavian Mitu. I work as a backend engineer here at Grid Dynamics. I will speak about backend part of composable architecture. Next, we'll go Vadim Darii, which is staff senior DevOps engineers. Our front-end expert, Andrei Balmus, and list Alexandru, Dobinda, quality assurance. So let's kick off the backend part. My agenda for today, I'll discuss about birth and evolution of e-commerce solutions, headless architecture, composable architecture in context of e-commerce or composable commerce, connecting to systems, and in conclusion, I will talk about our experience and lesson learned. So here is a timeline showing the birth and evolution of different e-commerce solutions. At the top, we have legacy monolithic applications like Oracle Commerce, IBM WebSphere, and Hybris. But today we'll focus on the lower part of the axis and try to bring differences, trade-offs, and benefits of so-called third generation of e-commerce. So why it's called third generation and what are the previous generations? The first generation of e-commerce was essentially basic stores that offered basic functionality, such as product details page, product listing page, stock, inventory, payment, and in general, all the basic flow of creating an order. Those platforms were built as monolithic applications, meaning that front-end and back-end were tightly coupled, which made it difficult to add a new functionality, scale, or customize. The second generation of e-commerce solved this problem by introducing the new type of architecture, headless architecture. Headless architecture introduced more flexibility and modularity by separating front-end from the back-end. This is a separation or decoupling. Several advantages of headless architecture: greater flexibility. With headless architecture, the front-end can be developed in any technology or framework, allowing for greater flexibility in design and user experience. Developers can choose the best tool for the job without being constrained by the backend. Faster development. With front-end and backend being separated, developers can work on their tasks independently and in parallel, which leads to faster development cycles and time to market. Improved scalability. Being separated, front-end and backend can scale independently based on specific resource requirements. Better integrations. Headless architecture solutions can integrate easily with our systems and applications, as they expose APIs and CDKs that can be used to connect with our services. Next, I will talk about composable architecture. Composable architecture refers to a modular approach of building software systems where different components can be easily combined or separated in order to create new applications or modify existing ones. Composable architecture is built from packaged business capabilities, or PBC. Packaged business capabilities is an important term which we'll discuss several times later in the presentation. Each PBC is a software component that represents a well-defined business capability through APIs and possibly extensible administration application. An extensible administration application is a user interface which makes the interaction with the system easy and friendly. In this way, composable architecture offers every business best-of-breed software components which are integrated or composed into a custom application that solves specific business needs. In other words, each PBC is a feature or capability that solves specific business needs, and it's typically a third-party software component. Several advantages. Flexibility. Composable architecture allows developers to quickly build and modify existing applications by pre-assembling pre-built components, which can be customized or replaced as needed. This makes it easier to adapt to new business needs and technology trends. Scalability. By breaking down software components into smaller independent parts, composable architecture can scale individual components based on specific resource requirements to handle increased demand and traffic. This makes it possible to achieve better performance and responsiveness, even as application grows. Reusability. Composable architecture promotes reusability by breaking down software components into smaller and independent parts, which are easier to reuse than their bigger counterparts. Interoperability. When component interface is small, we can change one implementation with another. So enough for types of architecture. We discussed 3 types of architecture: monolithic, headless architecture, and composable architecture. Now we will discuss about composable architecture in context of e-commerce or composable commerce. Here we have an overview of headless of composable commerce. In the center, we have headless e-commerce engine, or in our case, commerce tools, but it can be any other. And through the parts, composable services, or packaged business capabilities, as we previously discussed. The number of composable services were reduced for space, but we can easily imagine that we are not restricted on how many or which composable services we need to use. We are truly flexible in that regard. So composable commerce takes headless architecture to the next level, that is to microservice-based, API-first, cloud-native software as a service, and headless. If in the second generation only front-end was decoupled from back-end, in the third generation, everything that can be decoupled is decoupled. Content management system, customer relationship management, product information management, order relationship, order information management, marketplaces, tax management, address verification, and others. Every composable service represents the source of truth of their data and behavior. For example, order management system represents the source of truth of their order data and behavior. Therefore, if a client makes a request, it usually spans multiple composable services. And we found best practice to build an aggregate layer in front of them in order to simplify this process. This pattern is common in microservice architecture, and it's called backend for frontend. When an external system wants to communicate with our system, we don't expose composable service interface, but we build a microservice in front of it, and expose specific business interface. Therefore, 2 of the most important advantages of composable commerce is interoperability and flexibility. We can use the best products and services for our business model. That is, if a cutting-edge product comes out, it is easier for us to replace the old system and integrate with the new one. So here we give up the idea of one size fits all. and we have a possibility to continuously choose the best services for our business model. So now say we have chosen the best services for our business model. Now it's time to draw the lines. The lines are the connection, integration, or composition between services. Typically, we cannot configure service A to communicate directly with service B. For example, we cannot configure search and the recommendation engine to communicate directly with product information management, as their interfaces are incompatible. That's why the backend job is to build the lines between these services and finally compose them. So let's take a look of drawing a line connecting two systems. This is the most simple architecture. A is doing something to B. Now, how complicated this could be and what could go wrong in this architecture? There are several questions to ask, like, what is the interaction model? It is RPC or it's REST, maybe it's GraphQL. It is synchronous or asynchronous. It is pub-sub or point-to-point. More importantly, it is data or control flow. Maybe it's pulling, maybe B is pulling from A, but the data flows from left to right. What is the data format? We are building a distributed system, and in distributed systems, we have things like partial failures. So how do we handle the errors? Do we retry? If we do retry, do we have idempotency? If we retry too often, could we bring B down? Do we need some kind of backoff? So there's quite a bit behind this line. And as engineers, we need to know how this works in order to build a reliable system. So in conclusion, I want to speak about our experience and lesson learned. First, choose the technology stack. Here is about flexibility. In addition to choosing the cloud provider and the services, composable services, but best suits our needs, we have the possibility to choose entire technology stack that best suits our needs. Replatforming from scratch and incremental migration. We had experienced both replatforming from scratch and incremental migration. In case of replatforming from scratch, it works in a simpler way. Like you build your repository, push your code, and switch DNS records when it's ready. In case of incremental migration, we applied strangle fig pattern or simply strangle pattern. It is building a facade layer in front of your services, and by keeping the same interface, we change the implementation one by one, incrementally, until nothing remains from the old system. In both cases, we applied A/B testing, feature flags, canary releases, in order to deploy as frequently as we can and get early feedback from our users and roll back in case of failure or bug. Serverless mindset shift. We deployed our infrastructure on public cloud and used serverless as a model of cloud computing. But shifted our developer experience. Like I forgot the times when I clicked a line in the editor and the debug mode was on. Now it's possible to debug a serverless function, but it requires some additional steps. In case of AWS Lambda, we can create a local event and invoke the function locally. Azure Functions does not have this problem. Full stack development. Every serverless function requires at least some permissions, environment variables, memory, and timeout configurations. This is the minimum DevOps work everyone does, but we tend to shift our working mindset to work on verticals, that is, to work on every aspect of business feature. Of course, there is trade-offs, but we found in this way it's easier for business analysts to write user stories, and there is some less communication with and messaging between team members. So there is everything that I had to say. If you have any questions, please keep them at the end of the presentation, and I will invite my team Darii to speak about infrastructure. Thank you.
Guys, if you're online and you already have questions, you can just put them in chat to not lose them. If you're offline, you can just make notes on your phone, please. Thank you.
Thank you, Octavian. My name is Vadim Darii, and let's talk about infrastructure. When designing an infrastructure, we need to follow some infrastructure pillars. and make upfront design decisions for both software and infrastructure. If you look at the design in this slide, it is quite similar to monolithic applications. However, there are some differences. Let's review these pillars and see their relationship with composable commerce. So reliability, performance efficiency, cost optimization, operational excellence, security, and sustainability. Reliability means automatically recover from a failure. A composable application will recover much faster from a failure as each service is much smaller compared to the whole monolithic application. Scale horizontally. A composable application brings independent scalability. Each service may be scaled independently. Lambda function are started by request, and there are many instances. As many instances as needed, Kubernetes pods should be configured to use horizontal pod autoscaling, EC2 instances to use autoscaling groups. Fault isolation. If a service fails, only a specific functionality may be impacted, like processing a specific data stream, instead of impacting the whole monolithic application. Performance efficiency may be improved by using advanced technologies and serverless architecture. And here, composable architecture shows its real strength, as Octavian already discussed. Breaking a monolithic application into multiple services also leads to great cost optimization, as each component may be scaled up and down independently, depending only on the current load of a specific functionality. One of operational excellence pillar components is infrastructure as a code. It is also important to support frequent, small, reversible changes. The primary goal of an infrastructure as a code is to control the infrastructure using programmable, type-checked, and constructs trackable within source control. Primary goals are set up environments, organize user access to AWS resources, integrated CI/CD pipeline, integrating with monitoring and observability tools, assuming least privilege access principle, exposing applications and services for public access, integrate with identity store and service for to authenticate customers. Thus, infrastructure as a code approaches are integrated infrastructure and applications, and mixing collaboration model between DevOps and developers to operate with infrastructure as a code to build, test, and deploy new functionality locally and in the cloud. There are multiple tools to be used for infrastructure as a code, as widely known Terraform and Pulumi, serverless framework, AWS Amplify, AWS CDK. We chose AWS CDK for its flexibility and active support from AWS. We may use it infrastructure as a code written in the same language as the rest of the code, TypeScript. CDK team releases updates quite often, and community is quite responsive. There are lots of examples and libraries created by community. Its imperative approach for defining infrastructure stacks provides a lot of flexibility. With enough TypeScript knowledge, we will be able to apply well-known programming patterns to structure and reuse code and configuration. Its ability to automatically generate IAM permissions make it very appealing compared to Terraform. And you can manage almost anything in the cloud with CDK that is not applicable to serverless framework or Amplify. Next infrastructure pillar is security. That means strong identity foundation, traceability, and apply security at all layers. All of these aspects are also greatly covered by AWS CDK as infrastructure as a code tool. Another infrastructure pillar is sustainability, which means maximize utilization and use automation. In a traditional monolithic application, there is a single build pipeline whose output is the application executable. All development work feeds into this pipeline. If a high priority bug is found, a fix must be integrated, tested, and published, which can delay the release of new features. Following the microservices philosophy, there should never be a long release train where every team has to get in line. The team that builds service 2 in the picture can release an update at any time without waiting for changes in service 1 to be merged, tested, and deployed. Having separate build pipelines for each component makes it easier to react to failures. Thus, CI/CD implementation should respect the following principles: independent deployability, little and often approach, reacting to failures and fixing bugs quickly. That will be covered by Alex in the quality assurance section. Option to choose the language and framework for each component, containers approach, and last but not least, main branch must always be shippable. Traditional monitoring tools focus either on infrastructure, specific software components, or overall operational health. These tools are usually only moderately effective, but they may be sufficient for legacy systems with a monolithic architecture. Composable architecture hosts components in containers or virtual machines distributed across cloud environment. Thus, monitoring log aggregation is far more challenging. There are hundreds of services and instances. Thus, a centralized logging system is a must, as well as need for tracing. Measuring the ability of services to communicate with each other and deliver the expected result requires specific monitoring capabilities, like end-user experience monitoring that measures client operations and performance of browser and mobile devices, system interaction monitoring. This includes interaction between the end-user devices and the microservices and other components involved in the user's request, and end-to-end monitoring that helps isolate issues across the microservices environment. Let's see now how infrastructure design pillars and CI/CD approaches influenced other areas like front-end development and quality assurance. Let's invite our colleague. Thank you.
Hi guys, how do you feel? Tired? No? Okay, front end. It should be interesting, no? Front end always interesting. Yeah, I'm Andrei, and I'm going to discuss with you the headless and composable architecture from a front end perspective. It's slightly intersect with what Octavian said, but that's the beauty because we are doing pretty much the same things on backend and front end. So yeah, bear with me. All UI developers, if you are here, you probably know that monolithic platforms are usually tend to be large, complex, and it's difficult to maintain because of all the components tightly coupled and interdependent. And the headless architecture, like vice versa, it completely separates the presentation layer, or let's call it head, from the backend, and allowing each layer to be worked and developed independently. And that's the beauty. It adds this flexibility. Front-end teams can choose the best frameworks, tools, and patterns for their specific needs. And also with standalone front-end applications, we have more control over like HTTP. We can control stuff like caching, optimizations, improve the performance on different levels. Yeah, basically control everything. And that's basically important steps toward the composable architecture. And moving from composable architecture, from the monolithic to composable and through the headless architecture doesn't tend to change too much from a front-end perspective. But it does provide greater flexibility and the ability to reuse different components. And from commerce tools, from a commerce perspective, I can give you an example of checkout. I think you all know that page. When you buy something, you have to go to checkout page and do the order placement. And it's actually a most complex page on the commerce because it has a lot of functionality, integrations like payments, forms, validations, and so on. And imagine you can reuse that piece of code on other projects, and that's actually save a lot of time. And yeah, reduce duplication of effort and establish consistency as well. Composable architecture also enables other advanced features like no-code features and micro frontends. With the no-code features, no technical team members can adjust, can change the application without writing any code. And this can increase productivity drastically and speed up the development process. And micro frontends, on the other hand, splits the complex storefronts on smaller parts independently. Development can be done and also can be deployed independently as well. With all this, you have like imagination of on the one side we have multi-service applications. On other side we have multiple storefronts, and we have to combine it and somehow develop. And because of composable architecture is popular in modern web development, however, the management of such projects become complicated because of code base growth. And to make that work effectively, we need the right tools. And monorepo is the first tool that we use. Monorepo has many advantages, but the key features that we should look at are understanding the project graph without extra configuration, running tasks in correct order in parallel, treating different technologies the same way, determining what might be affected by a change to run builds, tests, and deploys only for affected packages instead of the whole project. So yeah, if you'd like to learn more about monorepo, there is a site, very cool site, monorepo.tools. You can go there. There are a lot of interesting information. The next very cool feature is code sharing. It's pretty much related to monorepo, but I split it to another slide because it's very important. And with monorepo, you can easily share the code between the packages, and it was very useful from our experience, where we were able to import the backend code to frontend, or we were able to reuse types from backend. And imagine if something was changed in some of the servers, the frontend saw that during the build, or even if you configure your ID, you will see it right away. So yeah, by sharing utilities like filters, validation, types, you can make the code consistent and efficient. And also using centralized code quality tools, you can make sure that your code style and test coverage is consistent as well across all the project. Another feature that really help with such architecture is API orchestration. And API orchestration is a huge topic and requires a separate presentation, but I'm going to highlight a few points and advantages. And using the API gateway or BFF pattern makes it easier to maintain and modify APIs, because you're able to change backend without affecting the front end, and vice versa, of course. The purpose of having the BFF is to provide your client a focused interface to connect with. As you can see on the image, there is a different BFF interfaces created for different clients. And with that approach, the BFF tend to streamline the data flow and introduce a lot of efficiency to your application. Of course, comparing with standard API gateway, because it's different. And yeah, using the BFF allows you to hide sensitive information from the services of backend. For example, you can omit unnecessary errors from the service that can be sent to storefront, or yeah, other information. And that abstraction layer can also complicate make it more difficult for attackers to target the application, which improve the security, which is great. And yeah, also I wanted to mention some stuff that we've learned as a front-end developers and features that helped us a lot. The first one is continuous integration and deployment practices can help catch errors early on development process. Also carefully consider the BFF orchestration approach. Ideally, the front-end team will be responsible for managing the BFF as well. And yeah, don't forget to split BFFs by application interfaces. With more code on the front end requiring error handling. So it's very important to have a robust error handling strategy to catch and handle errors effectively. Using TypeScript can also help catching errors and reduce the risk of issues on production. And in tandem with the CI/CD, if anything changes in the service during build, you will see that your components are not aligned with types, so you will see the errors, which is great. If you use monorepo, the pinned version of packages also helps, but sometimes adds some complexities during the upgrade. So you have to consider the systematic upgrade process. Also try to identify the data you need as early as possible and load the components and data in parallel. And also when it comes to some long processing tasks like, I don't know, order processing, using an asynchronous request reply pattern can be incredibly useful. And by separating the request and response phases, we can avoid blocking the user interface and ensure that our application remains responsive. So here as an example, you can see the loader and the message. So instead of having a loader, we can show a message like your order is in process, we will notify. And if the user is still on the site, we can show another message that order is placed. Or if the user left the site, we can email them that order is placed. That's the idea. And at last, I also would like to highlight some features that it worth to look at, because the first is related to MPAs, multi-page applications. Because if the page or websites with the low interactivity, React or SPA in general isn't necessary, especially when we want search ranking, high search ranking. In this case, we need very fast startup. So in this case, it may be more beneficial to focus on being HTML first and use multi-page application instead of SPA single page, or at least to use mixed. And we use actually mixed all the time. So some pages are MPA, some single pages. And good news is that there are plenty of frameworks that support this approach out of the box. I put a few examples like Astro, Marco, Remix, and Next.js. Another thing is streaming is also a big theme, and just a few notes about that. The streaming allows flashing HTML early, so the browser can progressively render it and start processing any render blocking resources like CSS and JavaScript, while the backend fetches any data simultaneously. And by doing so, many round trips stuff that normally be sequential can be parallelized. Other event-driven architecture point is actually a best friend of composable architecture, and this architecture can resolve a lot of problems. For example, coordination of microservices, scaling, error handling, and retries mechanism. And by the way, also coordination between the development teams. And my final words, when it comes to choose the best framework, approach, or pattern, there is no one-size-fits-all solution. We should carefully weigh all options we have and consider specific needs before making a decision. And yeah, the good news is that we have all the options. We have great tools and yeah, to achieve. Thanks, that's me. And now next presenter, Alex.
Hello, everyone. My name is Alex. Hope you enjoyed so far the presentation from my colleagues. And good news is the last part. And we'll speak now about the quality assurance. And the question is how we're going to test all this stuff. Big new architecture approach of building commerce solutions for the business. Okay, and first we'll have to think of three points that I'll try to cover here is how we actually approach the strategy when it comes to composable architecture, what techniques we'll use for testing, and how we are going to ensure that the code that is built will be delivered successfully in production. And yeah, let's start with the strategy. So basically, it's like with any other project, we have to know the product we are going to work with, and we'll need to know what will be the industry, what are the stakeholders, what will be the integration points. We look to answer a number of questions like what will be the environment setup, technology stack, what will be our scope of work. There can be many other teams working on the same projects, and yeah, we'll need to decide on the team profiles. All these aspects we'll go on to answer, and we actually consider all this in the traditional, more traditional architecture as well. But here in composable commerce is because it's a commerce system built from PBCs, which are the package business capabilities that Octavian already mentioned on his part. We know that now in this diagram, for instance, it shows that on the left, we have the monolithic architecture. On the right, we have the fragmented microservices. And right in between, which gives less rigidity and more flexibility, is the package business capabilities architecture. And with that, we actually already from the start, when the team does the discovery, gather all the information, we already know with what services we are going to work. And important thing to mention here that all these services are actually the working software components, production-ready solutions, and all these are actually exposing APIs and provide SDKs for using the interaction with those APIs that we can leverage in the automation. And another point, which also was really good mentioned by Octavian, is that there will be really a lot of data flows going back and forth within these software components. And just to note that before all these software components start working together, it may take months, yeah. And as a QA team, we actually should be ready to interact with those in isolation as the development progresses. Thus, knowing all the available services, we can go alongside with the development from the early beginning of the project. Now, once we know actually that we work with the services, so we need to think how we actually approach the testing itself. So probably most of you heard about the shift left testing, which actually says acting earlier within the development process. And as I mentioned that we actually have these APIs, we have the services, which are production-ready solutions. We can, from the beginning, already start interacting with those. We can start testing and validating the schemas, start testing the configurations. But we shouldn't actually forget about the, exactly in this place, we need to think about the automation actually, because all the level of integration part, it should be really automated, and we should have really quick feedback from what's being developed. So this will help us to provide fast feedback and get in-time resolution. With this approach, we'll need to take consideration that we'll need to have a really good collaboration between QA team and developer team. So it might be a problematic if you have a completely distributed team for testing and completely distributed team for developers. But in our case, our experience, we have a well-structured team with developers, front-end, back-end, infrastructure engineers, and quality assurance engineers. And this collaboration between us helped us to progress and be successful with this testing approach. Once we actually decided on the way we are going to test, we'll need to think how we are going to deliver and make sure that the thing that we deliver is actually working solution. And for us, what we actually adopted was the continuous delivery strategy. But before getting to that, I would like to highlight a number of aspects that need to be considered before you actually go with that strategy. And taking one by one, automation testing. The complexity of the testing, composable commerce implementation are mainly now centered around the integrations, as mentioned before, and component testing of each service isolation. So some risks are now moved from the inside the service itself to the integration part, and that actually makes us to think to change a little bit the traditional testing pyramid. The pyramid was actually a really valid approach for monolithic architecture, but for composable, because as mentioned, we actually move from inside the services to the integration part, we may need to think to have same number of integration tests as the unit tests, or in some cases, we may even want to have more integration tests than unit tests. And that will bring us to the approach of house of testing instead of pyramid of testing, where we have like the same number of unit tests, integration tests, and then we have the end-to-end test on the top. Here is with the automation, so we'll need really to think on the tool we are going to choose, considering the services we are going to interact with and the level of tests. Another point is to consider are the feature toggle. So feature toggles capability should be considered for functionality that are not baseline functionality. So imagine in a checkout, in a e-commerce website, you have registration functionality, you have sign-in functionality, you have checkout, PDP. So those are like baseline, which should always work, which will need to be really well covered by automation in time. But when there are some new functionalities like a new payment method, a new delivery method, a new, let's say, social sign-in option, or a new design for, let's say, same PDP, product details page, we should consider a feature toggle, meaning that we can at any time turn off and on that specific functionality in live without actually affecting the site. So you release a functionality, you see it actually passed all the tests, it's working, but at some point you notice some incidents in productions, you don't have enough information, but you know you have this particular release, so you can toggle off the specific functionality and get enough time for investigation and troubleshooting, right? So feature toggle should be, it is a powerful tool. And here another thing to mention, it's not really about the A/B testing, although it can be a support for A/B testing. So you can build a functionality that you want just to enable for a week or two, for instance, but here is more about controlling and quickly reacting to failures rather than sitting and creating hotfix over the nights and so on. Another point to consider is the test data, which is really important in any architecture or any project. But here is to consider that working with various services, you need to make sure that you can really easily restore data. Also consider that you have to continuously deliver new code to production. In case of some re-needs of the system, you have all the data ready to re-need, to restore data, or to migrate to another environment if that's needed. So these aspects are also is important to be considered. Next three are the documentation. Documentation, again, it's not something new actually, but it's really problematic when the team doesn't really know what are the available feature toggles, for instance. What are the configurations? What are the services? What are the endpoints and communication with the servers or another? And here again, we need to react quickly. So we need to have really well-structured documentation so we can get to that and know how to progress in a case or another. Another aspect which I would say is really critical in case of continuous delivery is how we approach the monitoring. And I mentioned here, it's actually consists of more parts: logging, monitoring, metrics, and alerting. Logging, really, again, we really need logs for troubleshooting. We need to have evidence of the data flows. When it comes to integration, we need to understand what we actually sent, what we received. We need to get the payloads. We need to being able to enable debug if that's needed really quick for a deeper investigation of a problem. So all those capabilities should be available for with our tools. For monitoring, we need to have logs properly aggregated, which will give us graphs for a better observability to analyze the trending on aspects like increase of request on a specific resources, increase in errors, and so on. Metrics, which can actually, you will not have from the beginning of the project, but you need to consider those, and you should actually get some valid metrics for your system shortly and put those and keep those updated. With the metrics, I mean, you should understand what actually are, let's say, number of concurrent users on your website daily, what are actually the average of bookings or orders being placed in a regular day, or what are the resources used by your system in terms of CPU or memory, and also like let's say the status of the queues in the services. Knowing those metrics, you can react quickly, and all those are really useful. You need to have in place. But another last point with alerting will give you the fact that you'll have automatic notifications triggered based on your configurations that will check the system healthiness. So again, this is something that your team will need to consider, adjust, update, and add. So you have alerts on some error increase. You have alert on some, let's say, dead letter queue for a particular queue is increased drastically, right? So you have all those alerts in place. You are notified instantly, and you don't have to stay daily and check the graphs or the logs. This, as mentioned, is important part, and this is actually a thing that do the connection between the development team and the support team. Yeah, we have our support team, Grid Dynamics, that does the monitoring and support for the applications that are live. And for a fast and efficient mitigation of issues of any kind, there should be a clear understanding of the system behavior between for both for developers and for the customer support team as well. Yeah, that's about the logging monitoring, and the last one is the release. With the monolithic approach, we actually were considering releasing once in 2 weeks, 1 month. There was a lot of documentations. There were like strict timelines for UAT, let's say a week for UAT. So with a continuous delivery, if you decide to go with that, you need to forget about those aspects, and there will not be hot fixes. There will not be, let's say, rollback releases. For a continuous delivery, there is just go forward approach. As also mentioned by Vadim, if there is a bug in production, it wouldn't block another feature to go live. Instead, you just create a fix and deploy it right away. And yeah, we should also forget about the strict processes documentation, as already mentioned. Yeah, because here, once you have a feature ready, you have a feature toggle built for it, you have executed the automation test, you have the result, you can deploy it to production. And all these aspects are need to be considered. And once we already reviewed, decided, and we are now agreed all to go with the continuous delivery, let's talk a little bit about that. And this is a simple representation of a pipeline in continuous delivery, really simple one. And with Composable Commerce, it's easy to adopt such a strategy because we have the code all differentiated in packages that represent segregated components of the product. And with that, we can build and deploy packages in parallel, having new code available on your environments fast and without downtime in the most of the cases. And here, what we see on the on this image is actually we have our team, which is building the code, developing the product. There is a pull request which is being merged. In a particular pull request, we have the second square showing the packages. Again, just 4 packages, which is order management system, integration application layer, B2C and B2B. Let's say there might be even more packages. In a particular pull request was affected as the B2B, for instance, which I highlighted here. That particular package is being built and deployed to an environment. Again, you can have smoke testing, staging UAT. You can as many as environment as you need. Once it's deployed to an environment, you run your automation. Again, knowing what package was changed within the configuration of the pipeline, you can specify and run that particular package for that particular automation package for that particular service of package of services, right? Which again minimize the time, so you have really quick an update on the results. Again, you can decide to have another, let's say, more general end-to-end test for checkout, for instance, full test at the end of that one. And once that's passed successfully, you have the step for manual approval. And here is actually the difference why we choose to go with continuous delivery. Because so far everything is automated, and with for instance, with a continuous deployment, you'll go even the deployment to production automatically. But with the Composable Commerce, there still might be some dependencies with some systems where, for instance, we may need time to test and get feedback from some services. That's why we need this manual step in between to make sure that we review the results, to make sure that everyone is aware that there is a feature toggle, agree with the business whether do we enable today or tomorrow or in a week, but they should know that we release the feature today in production. And once we get those minimal communication moments, we can deploy production. Again, it can be a single pull request being built, or it can be a number of pull requests. Again, it's decision. You don't have to deploy every single build, right? You can skip and deploy, let's say, 10 builds together. And yeah, it starts from the beginning. You have a bug, so you create bug ticket, fix, deploy, fix, deploy. That's the continuous delivery pipeline. And yeah, I'd like to highlight a number of benefits that we have seen, a number of risks. So yeah, as also Vadim mentioned, that it actually gives us a possibility to deploy small and often versus big bang releases with the monolithic approaches, where I said that you can have a release one in a month. You are flexible and fast versus rigid and overwhelming release cycles in more traditional release strategies. However, you'll face a number of risks here, which you'll need to consider and be aware of. The QA team is, again, it might vary from a team to team based on their profile, which I mentioned at the beginning. With the test strategy, you'll need really to consider your team profile. But in any case, the QA team will spend much more time on pipelines. For instance, the automation part, the QA team will need to take care of that, making sure you run tests in parallel. You don't have automation tests running hours, because you need to have really quick feedback and don't block other processes. You also need to understand and adjust this pipeline. Your attribution will be for the manual approval. You'll need to take care to really know what's being merged and what's going to go live, so you are aware of the feature toggles and many other things. The thing that is benefit saying that we deploy small and often actually gives us another risk, which is production is changed more often. And when people decided to go with the big bang releases one in a month, they try to touch the production rarely. So there is like, it can't break that often, let's say. But here you change production, it can be 2 times a week. It can be even every day in a week. It may happen if you have some fixes or small features that you just can decide to deploy every single day. So production will change often. When you deploy production, obviously there are risks. So you'll need to pay attention to the monitoring, to the logs. Your team will need to look into the logs. And that's why I said that alerting, monitoring, and metrics will be really helpful and will save your time. And yeah, again, with the QA team profile, it requires more knowledge than just manual testing. You'll work with, again, you can split, but you need to consider that your QA team should be aware of how continuous delivery works, should react quickly to understand all the integration aspects, to understand how the system communicates. So there will be a lot of aspects, and learning curve here or onboarding on such a project will require your QA teammates to have some expertise beforehand. Yeah, this is about the continuous delivery, how we deliver. And now, yeah, we are at the last slide, and we put here actually with our composable work a number of words, yeah, which we wanted to highlight the variety of available technologies, tooling techniques, and importance of building a well-skilled team with appropriate knowledge and expertise for the puzzle the business is looking to assemble. On the slide, yeah, we have a number of the words, the key figures in a composable architecture, but there are even much more which will describe and give benefits to your team when working with such project. So this is my last word in the presentation. I want to thank everyone for listening, for your attention, and now it's time for your questions. Thank you.
Thank you, our speakers. Thank you very much. I have a note that please, while asking this the question, please note to whom this question is, so it will be easier to answer on it. But now we have 2 questions in our chat, And maybe the second will be the first question because it is for you, Alexandru. You have been mentioned automation. Which tooling is proposed and how do they integrate to the development life cycle? What is the release strategy and sign-off strategy is best suited for composable commerce?
So for the tools, we have experience so far with 2 projects, and in one case, we used a tool that actually allows us to test both integrations and end-to-end test. So we used Cypress on one project. On another project now we're use Playwright, which gives us possibility to test on the API level and also easily test on the end-to-end. Besides that, that gives us possibility to do visual regression, and accessibility as well with a number of libraries. With the release strategy, probably I already covered in the last slide. So yeah, for the sign-off, we agree with the business. Here is the process, here is the strategy. We deploy, we inform you, we are notifying what feature is live, we are giving you timelines. Even though the business is not ready for the particular, let's say, campaign, we still deploy to production, not to have a queue of the builds, but we keep it toggled off. So this is all communicated to the business right at the beginning when we start with such strategy, and they are like aware of how we do releases. Hopefully this answered the question.
Thank you. Denise, is it okay for you, this answer? You can write in chat. And also we have a question for, I think, both for DevOps and FrontEnd. So, but I think maybe mostly for Vadim. What best practices for TypeScript code DevOps team use, and how many practice cross with the front-end development team? What tool helps with it?
Okay, so related to best practices for TypeScript, so we use usual best practices like using interfaces and extending interfaces to reduce duplications. We define and use types where appropriate. We also define and use naming conventions. Also, as best practices could be considered used tools, we use ESLint and Prettier, also Markdown. As related to the crossing with front-end development, so mostly we cross at composing CI/CD pipelines, and also when creating containers to pass, for example, environment variables required for the UI component to run on Kubernetes pods. Also, when performing upgrades, there are sometimes dependencies count, and we get in touch then when some upgrades from the infrastructure side has a big impact on front-end dependencies. Also, I would like to complete the answer for the previous question related to automation. If you mean CI/CD tools, we use both AWS code build and code pipeline, and also we use the GitHub Actions. Both of them are good. Integration with development lifecycle, also I will complete a little bit. We use separate pipelines for builds from pull requests and for builds from the main branch, and different components, not components, different steps could be executed in each case. That's all, I suppose.
Thank you. We have thank you also from both guys who asked questions. Do we have other questions? Maybe offline, in person, we have some questions, or online. You can also use your microphone if you're online.
So the question was, how do we share the types between front-end and back-end? Yeah, so there are, there are different situation. For example, we have GraphQL layer, BFF layer. When the code is first, we write the code, and based on the code, the schema is generated, and based on schema, we generate the types, right? So there is another situation, maybe when the service implemented in a separate package, then it might be that it depends on the tools they use, but they can generate the types for us automatically, or maybe they just basically write them manually and we import to the front end. But it always goes like from the backend to front end, because we mostly reuse the data they implement. So yeah, hopefully.
So to not break the new functionality, do we use also feature flag on the specific microservice or micro content, or only for the entire application?
Yeah, if it's well, if it's composable, it makes sense to do it for some specific functionality or component itself. And in case you change the API, but you don't want to change the component, in this case, you have few options, like you said, feature flag, or maybe you can have a version, like you can version your API. So you just use the older version of the API. In this case, your application still works.
Okay, so no questions offline as I see. Online, maybe someone wants to unmute.
I think we will have maybe when we disable cameras and microphone.
Okay, so if someone will have questions like tomorrow or day before, after tomorrow, we will have the recording and you can ask questions in the comments and I will send them to our speakers and answer you. Thank you guys. Thank you all of you for joining and have a good day. And in the office, you will have some treats and have a good time.